Welcome back to Startup Hack. With my 25 years of development experience, here at Startup Hack, we turn beginners into full-stack developers in as little as 3 months. So with today's video, we're diving into the world of C# and .NET Core. We'll unravel the intricacies of static class memory allocation, a concept crucial for effective and efficient and optimizing software development. Through this explanation, we'll demystify how memory allocation works for static classes and show you how to leverage this knowledge to write more efficient and scalable code. So let's dive in. All right, so let's get started today. Now, make sure that you like and subscribe to the channel because we try to bring you great content. Also, we always make sure to post these code samples, so check the link down below and make sure to pull down the code samples. So let's dig into static classes in C#. So in C#, a static class is a special blueprint that cannot be instantiated. In other words, you cannot use the new keyword to create an object of a static class. Its members are accessible directly through the class name, making it a perfect candidate for utility functions, constants, and singleton-like patterns. So now make sure you like and subscribe to the channel because we always try to bring you great content. All right, let's dive into this today. So now we can see that in this case, we have a public static read-only string, API URL, and in this case, we created a whole public class called app_config. Now, this is something that you would pretty frequently do because an app_config class is something that you may use on every single app. And so you can have your API URL, you can have connection strings, and then you can set some static configs in the constructor. So now you can imagine some of these might come from a file or an environment variable. But then all you would do here is that you can actually access them later in other places in the code without instantiating the whole thing. So this static class becomes a great way to group some of these things. Now, one of the great things about a static class is static classes and their members live throughout the application's lifetime. The .NET garbage collector does not reclaim them since they're rooted in the application's domain. This permanence is beneficial for frequently accessed data, but requires careful consideration because you want to avoid memory leaks in long-running applications. All right, so let's use another real-time use case, which is like a logging framework. I know I frequently will use a static class for a simple application that it uses a logger. If you're using a larger application with dependency injection and some other things, this may not always work best, but if you have a really simple application, maybe like a simple web API, then a good class static logger here works really well. So you can use your constructor that once the application starts, it sets up all the configurations one time, and then this is then used as you do the logger.log. So you can do things like this, and say, hey, the application has started, and no need to instantiate it, and then you can reuse this all the way throughout the code. This is great if you're going to use something like App Insights or Azure Logging so that you can log, but maybe you want to wrap it with some other logging or something else that you need to be done with your logger. So this is a really real-world use case and something that's very handy to use frequently. All right, since static members are shared across all threads, ensuring thread safety is paramount. So use synchronization techniques such as lock statements or concurrent collections to prevent a race condition. So in this case, we have a thread safe counter, right? So this is another great time to use a static class. So we have the count, we have the lock object, and then as we use and call this method, you can see that it calls lock. This will allow you to then be able to increment this and to lock it as this is incrementing so that multiple threads can't do this. So this will ensure thread safety across the application. So while using static classes are useful for global access and utility methods, the singleton pattern allows for lazy initialization and control over instantiation, offering more flexibility in certain scenarios. So after understanding the basics and seeing static classes in action throughout real-time examples, it's crucial to delve into best practices and advanced concept to fully leverage static classes in .NET Core applications. So as we briefly touched upon, thread safety is a critical consideration when working with static classes, especially in multi-threaded environments like web applications or services. The static constructor itself is thread safe as it's called by the CLR and guaranteed to be executed only once. However, any static method or property that modifies static fields must be carefully managed to avoid this. So in this case here, we have a concurrent cache. So we can see that the static concurrent dictionary is initialized here, and then as we add our update, you can see that this is done in a thread safe way, right? And this will allow us to, and so you can see that as we use for collections, preferably using thread-safe collections provided by .NET, such as a concurrent dictionary or a blocking collection, or other types within the system.collection concurrent namespace. So that's this concurrent dictionary, as well as other different type of collections as well. Now, given that static members are alive for the duration of the application, it's essential to use them judiciously. Overuse can lead to memory bloat, as these objects do not get collected by the garbage collector until the application domain unloads. So you want to go to the best practice and limit your use to immutable data or stateless utilities. Use static classes for constants, configuration settings, stateless utility methods, or well-constrained instances that you know won't lead to memory leaks. Avoid using static classes to store large data sets or user-specific information that can grow out of bounds. So you can also use static classes in dependency injection, as we're seeing here on the screen. One criticism of static classes is they can make unit testing and dependency injection more challenging, as you cannot substitute static methods with mock implementation easily. So you can combine with a singleton pattern or use static interfaces. In .NET Core, you can achieve the best of both worlds by combining singleton service registration with DI to maintain testability and cleanness in your code. So you see here that we have the public interface iLogger, which then has the log method, and so then which is this is just the interface for it. So then you can actually see the implementation of the log class down here. Right, and so we still are getting to use dependency injection while still getting to use a static class. Then down here, as we say services.add singleton, you can add the iLogger, right, to your startup configuration, the interface, as well as then the logger class. So this allows you to get the best of both worlds. So static constructors in C# are only called once before any static members are accessed or before an instance of the class is created. However, if an exception is thrown inside of a static constructor, the class is rendered unusable for the lifetime of the application domain. So for best practices, you want to be able to handle exceptions gracefully, right? So we have an example here on the screen. We can ensure that any code within a static constructor is wrapped in an appropriate exception handling block to prevent application-wide issues. Log these exceptions, and if possible, make sure to fail gracefully. So elevate your journey through the landscape of static C# classes in .NET Core. We can delve into advanced patterns and techniques that harness the full potential of this. So let's dive in next to the design patterns that enhance static class use. So we can see a design pattern enhancing static class use here, the facade pattern for simplified APIs. So a facade pattern, static classes are excellent candidates for implementing the facade pattern, providing a simple interface to a complex subsystem. This approach can simplify the usage of various system components, offering a unified static gateway to more complex operations. So we can see here we have the class system facade, and then we have our public static perform operations. So here we can see complex system part A and initialize, process data, and then complete operations. Now, this pattern is particularly useful in scenarios where you want to abstract the complexity of a system behind a simpler static interface. Now, we also have the strategy pattern for dynamic behavior. While static classes cannot implement interfaces or inherit from other classes, they can be used in conjunction with a strategy pattern to allow dynamic behavior while maintaining a static interface. Now, we can see in the code here on the screen that we have the strategy pattern for dynamic behavior. We have an interface for IOperation strategy, and then we have the operation executor, right? So this is the actual static class, which then includes the IOperation strategy static class. So while static classes cannot implement interface or inherit from another class, they can be used in conjunction with the strategy pattern to allow dynamic behavior while maintaining a static interface. By combining static methods with strategy interfaces, you can change the behavior of your static class at runtime, enhancing flexibility. Now, as with everything, make sure you pull down the code samples, because these can be really handy, and you can take these code samples and be able to use them in your code. All of our code samples are free, and if you go and check out the page, you'll see that there's hundreds upon hundreds of code samples out there. And make sure you like and subscribe to the channel, because we try to bring you valuable content. All right, in distributed systems, static classes can play a pivotal role in providing global access points to shared resources, such as distributed caches, configuration, or service clients. So a singleton service instance for distributed access, you can use static properties or methods. You can using static properties or methods, you can provide streamlined access to singleton service instances that are essentially in distributed environments, ensuring that these resources are efficiently shared and managed. So we can see in here we have a distributed cache access, which allows you to use a static class and then to be able to distribute this iDistributed cache properties. So these static methods are to interact with the distributed cache. Having explored the advanced concept, design patterns, and optimization techniques for static classes in C#, it's time for us to dig in to address some of the nuanced challenges and opportunities that come with using static classes in complex .NET Core applications. This section aims to extend the discussion, and we can focus on real-world scenarios, performing considerations and best practices for integrating static classes seamlessly into modern software architecture. So let's talk about cloud-based environments and scalability. So for cloud environments, they can offer immense scalability, but they also demand that applications be designed for distributed operation. Static classes with their application-wide state must be carefully integrated to not impede scalability. So the strategy here is we want to combine static classes with distributed cache. In a cloud application, combining static classes with a distributed caching solution can provide both performance benefits and scalability. Static methods can serve as an interface to distributed caching, abstracting away the complexities of direct cache management. So we can see here we have a static class cache manager, and then we have the iDistributed cache, and then we have the initialize method, which then abstracts this away. We can then have a method like get cache values async, and we can do this and abstract this away using the performance gains of static classes while abstracting away from the rest of the application how this is working, and then still making sure that we can use this in a distributed cloud environment. So these are just a few of the examples of how we can use static classes, and hopefully I've shown you some pretty new things that you can do with static classes. They really can be very powerful as you use them correctly. So as .NET Core continues to evolve, so too will capabilities and best practices surrounding static classes. Future versions of .NET Core may introduce enhanced support for static class patterns, optimizing their performance and integration with new .NET Core features. So we want to make sure that we get really, we want to make sure we stay really up to date with how to use static classes. They hold a unique place in the .NET Core development ecosystem, offering both opportunities for efficiency and challenges in application design. So make sure that you dig into this. If you don't understand it, you can dig in and learn a little bit more. But I know that here at Startup Hack, we love to train software developers. With my 25 years of development experience here at Startup Hack, we take beginners and turn them into full-stack developers in as little as 3 months. So make sure to like and subscribe to the channel, and we will bring you some more next time. Make sure you like and subscribe to the channel because we bring you lots of great tutorials and tips that every developer should know. See you next time.